Hello CAE users, welcome to Passion to Flirt with CAE for CAE engineers and freshers. Today in this session we are going to discuss about how to set up a gravity analysis using Hypermesh for Nastran. So why we are going to carry out this analysis means by virtue of any whatever the structure, so by virtue of itself bit how exactly it will behave. So what are the effect on the structure, it may be displacement, stress or reaction forces, so those things we are going to discuss. So apart from that there are so many other applications are there using this, so we will discuss step by step. So before going to start with that, quickly we can create so FE model. So in this, so I'll take the simple frame, right? So these frames they are welded with each other. So in heavy engineering and all, so we are going to weld with each other by node merging method. This is the method what we are using. So go to shift F5, and in that you can select between and comps, you can select these things. So now you can see all these nodes are merged properly, so with which what we can understand, it is welded properly. If wherever it is missed, so it is not welded, right? So this simple frame, so these are the frames what we are using to carry out to lift some masses or some loads, right? So I'll show you the setup. So you can see already we created the material property. It's made up of steel. So Young's modulus, Poisson ratio and density is there, right? And properties assigned, right? So in visualization you can see the property assigned. Initially we assigned this one. Now I'll show you, this is the CG where exactly, so I need to put a mass on the structure, right? So create component named as resets. So on this reset, so I am going to create lumped mass, right? So already this reset is created, right? So before going to create reset, I need to create CG. So go to F8 and these are the values. In X direction 1950, in Y direction 2500, in Z direction minus 750, right? So just create. So node is created, done. So you can keep only these things. So on this, so you can create a results. Go to 1D page, that results. So we are using RBE2, so it will distribute load uniformly to all connected nodes. So this is the master. Sorry, multiple nodes. Now go to results once again, select this and use here multiple nodes, so we can select at a time, so it is easy. And create it. So it is created in different collector, so that's why, so we can delete this. So, or we can rename this one. New result, right, and change the color of your interest. And then switch on once again all. So on the CC we created what? So using results, so we just need to create mass. So 2 ton mass I am putting over there. Pass, create a collector, create, go to 1D, two ton. So select this node. On this CG I am applying 2 ton of mass. So these are the con M2. So if you want to see, you can see now this is the con M2. So assigned mass, whether mass is assigned or not, to check that one, what we need to do, once again tools, mass calculation, select this element and calculate it. So now you can see total mass is 2 ton, right? So now go to load collector, create constraint. So here no card image, there is no card image we are using here. So at the base frame, analysis constraint, well, so reverse it and select this point wherever it is required. So randomly I'll select somewhere else. The main learning over here is how we are setting. So what are the cards we are using, and purpose of it we need to understand. That is the main learning over here. So and then wherever opposite side it is selected, you can deselect these things, and all degrees of freedoms are fixed. Now you can see this is 1 2 3 4 5 6, right? All degrees of freedoms are fixed, right? So then we need to create a load collector, that is gravity load. So here we are using card image as a grav, GRAV, right? Created it. See, G means acceleration due to gravity, that is 9810. And in which direction? So this is N1, N2, N3 means X, Y, Z direction. These are the vectors in which direction we need to apply. So now I am taking, so in Y, Z direction, that is I am giving 1. Okay. So So actually if I am using Z direction, so the structure orientation is in Y direction, so I can't use in Z direction. Instead of that, I can go ahead with in Y direction, make it Z as a 0, right? So then come back, then we need to define load step. So gravity analysis, whatever the name you want, you can. So this is the static kind of analysis, right? This is static analysis, so that's why linear static setup, and constraint you can select load step. So in this load step I am calling load, that's the gravity load I am calling, and create it. So here you can request output also. So instead of calling over here, in previous session in static analysis I showed. Okay, so now I'll show you so another way, that is in solution sequence can go. This is static analysis, that is solution 101, and come back. Param means the output, so output file request, that is param post. -1, so we can get a op2 as output file, and global output request. So in load step we are requesting no output request. So even though we can request here also. So what are the results? SPC forces, that is sorting and format, and stress, and check with displacement. So it is the displacement. So then come back. The setup was finished. Then export this file. Gravity analysis, right? That grav export this file. Minimize this. So this is the deck file. You can open with notepad or textpad. So this is the executive control section, solution 101, and this is the delimiter, and this is the case control section. In that output request what we did, displacement, SPC forces, stress, and loads. So SPC is 1, load is 2. Now you can see the same thing, the number is 2, as constraint, that is SPC is 1, and analysis is static analysis, and output request what we did. So the output request stress, displacement, and SPC forces, so which will update in the .opt format. So if you add a param post -1, okay, fine. So we'll run this and we'll check the result. It is running still. So the analysis was completed. Then check with fatal FATAL fatal. Any errors are there, we need to check. No fatals. Then go ahead with post processing. So you can load this. Right, then check with displacement, go to contour, in that apply. So now you can see the result. So 0.518 is the displacement what we can experience by this structure. So you can see this is the maximum displacement where exactly we are experiencing, right? And then we can see the SPC forces. So these are the place where exactly we constrain. So there we are getting reaction force because of the mass and self weight of mass applied and self weight of this structure, right? And stress. So these are the place where exactly we are getting. So these structures which will experience more stresses, right? So now once again, so go back. So in gravity loading, so this is very useful for model checkout. So here what happens means, so force, what are the force applied, m into z is there, no? So mass as well as acceleration due to gravity, which is applied at every point of the structure that has a mass. If you have modeling errors, means for example connectivity issue is there, so it will give error. So I'll show you that one too. So for example, go to 2D and detach. And here I am detaching. So now you can check out. So these elements we need to detach with this. See, connectivity. So there is no connectivity over here. Then if you want to check with shift F3, you can select this, so it will show the nodes. These are the place where exactly connectivity is not there. Then export the same thing. So before that, what you need to do, can delete these things, initially run file and export this file, and once again you can run the file. File is running still. Now before that you can, so file was run. So before that, what do you need to do, you can open notepad or text pad. You can search fatal. So here you can see the fatal 9050 means so pivot matrix is there, means connectivity issue is there. So that's why this is a very useful analysis to check the connectivity issues on the help, right? So next, so that's why, so this analysis majorly helpful for model checkout as well as by virtue of itself, but how exactly it will help us. So and even though, so this analysis, if assume that there are some companies who they don't have a dynamic solver to check the dynamic behavior, at that time we are using this analysis. But these are the for example majorly this gravity analysis, so to carry out almost all hanging structures are there, no? So for example full vehicle gravity analysis we are going to carry out, and exhaust system. So door, for example door sag and sag, if door is sagging on the hinge pin and all, to carry out such cases we are using this gravity analysis. So this is x equal to 5g, y is equal to 5g, z equal to 10g. So in general cases we are using x equal to 1g, 2g and 3g. These are the abusive cases, means worst case under roll load condition. So we are using these cases. So I'll show you this one how we need to apply the same thing. Just give connectivity to this model. So connectivity is missed, so that's why connectivity. Then so you can use a busy load, that is x equal to xz, yz, 1g, 2g and 3g. So z direction is, so here you can use one, so you can use, this is the z direction. The orientation of this model is so y, so you can use 3z over here. And so here what we used xz, yz, z, y and z direction. So 1 into z load, 2 into z load, in z direction 3 into z load, but the orientation of the model is in y direction, so that's why I'm using instead of z, so in y direction 3g I'm using, in z direction I'm using 2g. So after that you can export those, and you can, so even though you can define in different load step also. So grab abusive load. So in worst case under roll load condition, what will the effect of the structure if you don't have a, so for example vehicle running on a rough road or a smooth road. So if road which is having a humps, so for example vehicle which is moving with a velocity of 50 km/h, so hump suddenly, so in front of your vehicle hump is there at that time. So what is the structure which will experience the acceleration, means what is the force which will experience. So these are the abusive load what we can use, so with which we can find out the safety of the vehicle structures and strength of the structure. So in some cases what happens, suddenly in a road some ditch is there, so what happens, one wheel will go down suddenly, so because of that the structure will experience 2g, 3g kind of loads. So those kind of loads what we can call it as abusive load or a worst load. worst cases. So that's what. So under road load condition, vehicle will experience these kind of loads. So that's why, so we are checking these terms using gravity analysis. So now you can see displacement. This is the abusive load. So 18 point. So initially it was 0.7 something is there. Now it was 18.502 the displacement. So in x direction, what is the displacement? So it is 4.9. Maximum displacement is there. In y direction, in z direction. So these are the different loads what we can experience by the structures and SPC forces. So we can experience magnitude. You can check in different direction. You can check the. These are the place where exactly we are getting reaction forces. Right, and stress you can see. Even though these are the combined loads x, y, z, so we did combined loading, and after that we are checking the result. Even though you can create different loads. For example, we created in y direction, we can create in z direction, means so whatever the load is, so these loads, different loads we can create, and different load step we can create, and after that we can carry out analysis. So such kind of things we can discuss in later sessions in different load steps. So this is the purpose of doing gravity analysis. So whenever a structure, so simply I just want to explain the summary of this analysis. So this gravity analysis, so majorly we are using to carry out by virtue of itself, but how exactly it will deform, so whether it will withstand the load or not. So that's how we are going to carry out this analysis. Even though there are some in, so we don't have a dynamic solver, we have only static solver. So at that time what we need to use, so abusive loads we are adding. So abusive load means a vehicle which is running under road load condition, means, so for example, vehicle which is riding with a 50 km/h, so suddenly hump comes, and so your vehicle, or ditch comes, so ditch is there on the road, or rough road is there. So suddenly you are riding a vehicle 50 km/h and you are taking left cornering, means left side or a right side you are turning, and up is there. So in such cases the vehicle experience so loads, different loads which will experience that load, we are calling it as abusive load. If you don't have a dynamic solver, at that time we are using this analysis for the check. This is the application, major application of this gravity analysis. And so this gravity analysis majorly we are using for to check the model wherever connectivity issues are there, right? So I hope you understood this, and thanks for watching. Please subscribe the channel and hit the bell icon. So share with your friends. Bye bye.